Okay, so the goal of this lab is to display a static characters or letters or numbers. Same ones on the 4 modules. That's the first step. Right? Take a look at this. Show the same static numbers on all 4 display modules. The final result should show numbers from 0 to 9. Just take 9 pictures of it. Okay, shows 0 to 9. And the second one, use switch to provide binary inputs. Okay, so 3 switches will give you from 0 to 7, right? So 0 to 7, and show that decimal number. Oh, 4, I'm sorry, 4. Show the corresponding decimal numbers. That's going out of range. Yeah, so I don't think I was trying to let you guys having 2 different digits, 2 different numbers showing on 2 different modules. So let's do from 0 to 9, okay? 0 to 9. So the difference is the first one is getting an input directly from the module, from your code, and the second one is taking the input from the switch. Okay, so binary inputs from 3 switches is going to give you 4 switches to give you numbers from 0 to 15, right? 0 to 15, but we are not displaying anything bigger than 10 right now. So just simplify it. Okay, it should be pretty simple, but I didn't intentionally design it that way. So just from 0 to 9, okay? It could be on 1 module or 4 modules display the same thing, doesn't matter. So it's just very similar. You're not directly giving the number from the code itself, but you are taking that input wire from the switch from the top, okay? And here's an example about the display module you can consider to use. So definitely you can see that I'm using a register type variable here to take the X input. So you can imagine in your top, I'll give you a few seconds to look at this. Okay, this is the sub module. Okay, this sub module manages the display functionality of the design, and you can see X has 16 bits, 16 binary wires, and this one will eventually get shorted to the top, which is FPGA's switch. Okay, and whenever the switch got changed, and it will show up in here and eventually being given to this register data type. So the reason we have to have a buffering register is because I found out if I'm using switch as an input to a submodule, I just have to use a register type to buffer that input a little bit in the middle. If it's not true on your side, I mean, just let me know. But I found out I just have to have a register type in the middle to buffer it. How do I buffer it? It's like this. Okay, so X, like I said, X is shorted to the switches on the top. So if you draw, so we are designing a digital block, always think about input and outputs. So starting from a box in your mind, okay, first, and the second is inputs and outputs. What are the inputs and what are the outputs? Right, so for example here we got 4 wires for X, right? So these are X. So you can imagine in the top, we are connecting the FPGA top to it. So there will be switches being shorted to these X, right? Okay, so you need a buffer in the middle. That's why I have to have a register type within that display module to handle that switch input first. If I don't do that, I saw errors being reported in Vivado. So you try it. I mean, if you directly use this one, you shouldn't have any issues. So one quick question here for you guys. If AN, which is the enable, is a keyword, right? AN. If AN is given a value of 4 ones, are they all turned on or turned off? Are they enabled or disabled, the 4 modules. Take a look at this one. What are the ANs? ANs are here, right, on the top. See AN on the top, and ANs are on the top here as well, the same thing. And they are being, yes, they are getting disabled. Why? Because the PNP transistors. So it's flowing current from 0.3 volts down to these modules in order to turn them on, right? But however, if you look at the arrow here, right, it's flowing current that way. So you need to give a 0 in order to flow the current this way to give a collector, emitter to base current. So it's going to trigger a bigger current in emitter and collector. If you haven't learned analog yet, which is fine, but just let you guys know, you need a 0 to turn it on. So this point has to be 0. So all these pins are ANs. All these are ANs. So it's AN 0 to AN 3. So I have to give a 0 to turn it on. So in that case, at the very beginning, I want to turn them off as an initial state. That's why I'm giving all 1s to AN. Okay? And whenever the clock arrives, I update all the logic in here. So it's mainly updating this guy. Because X can change because they are connected switches. The state of switches are changed. Then you need another clock cycle to wait there. As when clock arrives, it's going to update all the switches value to the digit, to this register type variable. Do you have to worry about the clock? It's too slow. You are thinking like when your finger moves the switches and you have to wait for another clock cycle to make something happen. Do you have to worry about that? You are thinking the clock is too slow, your finger is faster than the clock? Yeah. You think after you change the switches and you have to wait for another, like after lunch and come back and see if the clock triggers everything? The clock is running at 100 megahertz, okay? So it's almost synchronized. You couldn't even feel that at all. So the clock's updating all the states within that always statement. Okay? So when digit changes, which is value handles the switch change, it's using a case statement to find out which one should be used, right? So if digit is 0, so pay attention to this one on the very beginning, on the first column of the case statement. These are decimal values. That's all right. So whatever the compiler synthesizer is able to recognize it. So even though you have a 4-bit binary number for digit, but it can directly use the decimal number here to match with whatever the cases are. It's able to recognize it, which is fine. So for example, digit here is 0001. Okay, it's gonna enter this number 1 case here. You can see the number 1 there, right? Number 1, the second line. So this one, it's gonna enter this entry and assign this combination of the binary numbers to G2A. So G2A is all the LEDs labels of the 7-second display module. You can have a reference over here. So see, this one is a really quick reference. It's a G2A, okay, for all these LEDs. So you want to be informed that the MSB here is what? It's G. That's the whole point. It's telling you that it's G2A, it's not A to G, right? So from MSB to LSB, it's G2A. So that makes sense because for the first one, for case 0, right? So only G is what? On or off? Only G is off because zeros are turning off the LEDs. Why? Do you have a very accurate answer for me? So the question is, why ones are turning off the LEDs? Just answer that really briefly. It's an interview question.
Because it's putting the diodes in your forward bias when you make one of them a cathode. That's a voltage. Across the diode.
Yeah, so the answer is because all these are common anode LEDs. Okay, signal lines are connected to cathodes, right? Okay, so ones are turning them off. The ones are turning them off. Because if you give a 1, it's reverse biased, so it's off. All right, so these are the code. You can use this module. Just fill in all these missed parts, lines, entries. Modify the code, disable any 3 of the modules, and let's show the number on one of these. Oh, this is so simple. Why do I have to add this one here? Just give a different AN, right? Just disable the 3 of them. Just let you play with the AN a little bit. I think this is probably one intermediate step in between the all the modules showing the same numbers or showing different numbers. You want to learn how to disable them. So disable 3 of them and see only 1 of them is on, and displaying the specific digit data here. Okay, so do that. It's a great booster. It's given to you, 20 points, easy. And the 4th one is show FLC on 3 of the display units. So they have to be different letters. I have to find out the code for FLNC, right? Have to find that first. It doesn't matter if you justify to the left or the right. Doesn't matter. Just have to show the 3 letters on the 4 modules, either 3 of them on the 4 modules. So remember in the lecture I talked about this a little bit. Let's recap on this really quick. So because all the cathodes, you only have one set of A to G signals. Okay? In order to display different numbers on different modules, you have to scan through all the 4 modules one by one. So you activate the first one, you disable the rest, and you throw that C to it. You throw the C's code to the module, so it's able to display a C on the right hand side. And then you, after, I don't know, maybe 100 milliseconds, it should be good enough, and you disable this guy, and you enable the second one, you throw the L's code to the data lines. And the third time, after 100 milliseconds, you disable all the rest, but only enable the AN2 here, this one, right? And you throw F to the data line. So in that case, you do this really quickly, doing it back and forth really quickly, and should be able to show an FLC on it. So if it's blinking, for example, you are seeing FLC is sort of like blinking a little bit. So what's the next step should be? What kind of modifications you should do with the code? It's blinking a little bit.
So like it cycles through it faster, so it's not like.
Mm-hmm. Yeah. So it's too slow, right?
Yeah.
You want to scan it faster. So in the code, if you want to scan it faster, what kind of parameter you want to change? So this display module doesn't have the code, but this is one of the code, I guess. The count max, yes. Okay, so SSC diff. So I was trying to differentiate this one from the previous one. So this is showing different numbers on the 4 modules. Okay, so this is example provided to you guys. So if it's blinking, should you make this one bigger or smaller? Smaller, right? Smaller number takes less amount of time to reach because of certain frequency of the clock. It's 100 megahertz. Bigger number takes longer time to reach it. Okay, so it's getting slower. All right. It's already provided you with the pattern that you want to program. So whenever it reaches counter max, okay, there are probably four different states, depending on which state you are in right now at the moment. You do specific things. Okay, so these ones are not FLC's data lines, the data signals. It could be something else. I think I put something else over there. I forgot. Okay, this shouldn't be very difficult. So static FLC on it for this task. For the one next to it, will be the rolling letters. Okay, so it's adding another COMMAX to it. Okay, and why?
Basically.
Yeah, it's basically rolling, right? So at this moment, you display FLC. It's very similar to the previous task. So display static FLC, but the thing is, after a certain moment, you just have to shift it to the left. Okay, so you need another counter or another COMMAX, and that one cannot be too small because you have to allow your eyes to understand it. Your brain takes some time to understand what's going on, what you are looking at. So let's do 1 second, for example. Okay, so like FLC, 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 and rolling back to the right. So in that case, I'm creating another COMMAX tool as a parameter, and which is 100 million. So for 100 million hertz, to reach this number, it takes 1 second. It's exactly 1 second to make some changes. You can see I'm having a intermediate variable here to hold, or to make the shift. Okay, to make the shift for AN. It's really interesting because I find out if I have an AN here directly connected to the top AN's keywords of the FPGA, and I cannot shift it. Just let you guys know. It's really interesting. So if you have, for example, in the sub module, you have AN here, right? AN here, and you connect to the AN of the keyword of the FPGA, and you are not able to shift, you are not allowed to shift the AN in your sub module, even though it's not a keyword AN. You are not allowed to shift it. So similarly, you have to buffer it, have an intermediate variable, I call it ANN, whatever. So it's a register type, ANN in the middle, right? So you can shift this, it's just 4 different flops, right? So it's definitely it's under control. You can do the shift, concatenation, whatever. You can do it, okay, with this variable, and eventually assign it to AN. So how to do that? It has to be at the end of the code. It's just simply after this always block. Let me see. Should it be after the always block, or should it be after the if statement? Yeah, it should be after the if statement. So you have a major if statement over here, okay? So it has a beginning and end, right? So if else, eventually after that else at the very bottom, you should have one line of code to assign ANN to AN. So you are not directly shifting AN, but eventually the clock, the rising edge of the clock will update it. Whatever being shifted in ANN will be sent back to AN. So you are shifting ANN, but eventually it's giving back to AN after that clock. So waiting for a clock to update it. Because you are not allowed to directly shift AN, like I just told you guys. Okay. So this should be doable. And do you have any questions on this at all? All right, you can start working on it. I'm gonna visit every single of you to do the Vim quiz. Okay. Just the very fundamental commands, no tricky ones. But depending on if you practiced, right?